dust to dust, ashes to ashes. Most things decompose. But 20th century technology has granted PCBs the gift of eternal life. Or almost. You can destroy them with great heat, but many countries don't have the facilities. Which is why the biotech approach is causing such excitement. PCBs have been around for 60 years. Was that long enough for nature to respond? Were there any bacteria that could dent the chemical's armor? That is what scientists from General Electric set out to find on a contaminated site in New York.
And indeed, almost every place we looked, we did find bacteria that could grow. This flask contains bacteria that have grown on the parent compound of PCBs. We then took that culture and added some PCBs to it to assess the competence of each of these different cultures for their ability to degrade PCBs. At the same time, we also purified the bacteria from this mixed culture into their individual components to ask the question which ones had the PCB degradative competence and which were the best. When we did that, we found over 24 pure strains, each of which had a different ability to degrade PCBs, several of which were outstanding, and it is those that we are now continuing our studies with.
In the lab, they have singled out a number of genes which produce the enzymes that actually do the work of breaking down PCBs. When bacteria containing one or more of these genes were sprayed on a test site, a quarter of the PCBs were destroyed. But it took 4 months. Genetic engineering could improve this 1,000 times, the scientists believe. Although whether these gene-spliced bugs will ever be allowed outside the lab is another matter. When tankers started to go down, a young scientist thought there must be a better way to clean up after them. The storms that wrecked the tankers also wrecked the contraptions designed to prevent pollution. It was back to buckets and spades, until the invention of the oil-eating bug.
And then get rid of the chloroform ether again.
Ananda Chakrabarty was the man who made the bug. But it took 5 years to establish his right to patent what was, in fact, the first living invention. Chakrabarty has been challenged every step of the way by people who think that what he does is dangerous and wrong. He does not use conventional gene splicing to create his cleanup bugs, but all the same, you won't find them in nature. Besides their main chromosome, many bacteria have extra ring-shaped molecules of DNA called plasmids. Each plasmid is composed of several genes. When bacteria mate, one can donate a copy of a plasmid to the other. This is what Chakrabarty exploits. To create a strain of bugs that can break down a complex chemical, he starts with one containing a suitable gene to begin the process. Other bugs are introduced with genes that will continue the job. Their surroundings and food supply are manipulated until the shuffling of plasmids produces a new strain. A strain in which all the useful genes are combined.